All right, so the other two molecules in chapter 13 that we need to talk about are amines and amides. So these are nitrogen-containing organic compounds. Amines are anything that has a carbon-nitrogen bond, like so. And then amides, remember, is when you have a carbonyl connected to a nitrogen. So an amine is whenever you don't have the carbonyl, the C double bond O, and an amide is whenever you do. All right, so these are two examples of these types of compounds, right? Methylamine and acetamide, and we're going to look in a little more detail in terms of how some properties of these molecules and naming of them and how they look. So let's start with amines. So amines are basically going to be organic nitrogen compounds, whereas if you imagine if you were to have NH3 like this, right, with a lone pair, the idea is you're going to replace one of those hydrogens or more with alkyl groups or carbon-containing substituents. So we can classify amines as either primary, secondary, or tertiary amines. A primary amine is going to have one bond that's a carbon-nitrogen bond. A secondary amine is going to have two carbon-nitrogen bonds. And then a tertiary amine is going to have three carbon-nitrogen bonds. All right, so again, that's just classifying it as a primary, secondary, or tertiary amine. All that means is how many of the carbon-nitrogen bonds that you have. Now, in all of these structures, you're still going to have your nitrogen that has a lone pair of electrons, right? That's what's mentioned down here. And that lone pair of electrons is omitted in the condensed structures. So you just have to remember that it's still there, right? So remember, nitrogens are always going to have three bonds and one lone pair. All right, so here is just some properties of amines. This should really be nothing new to you in terms of bond angles and shapes, right? Amines, because they have the three bonds and one lone pair, they're always going to have this trigonal pyramidal shape, which gives you bond angles of about 109.5 degrees. That's just kind of a reminder back from chapter 3 material. Now, that nitrogen in your amines can be in many different types of structure. So, for instance, in morphine and atropine and a whole bunch of other types of these types of components or compounds, the nitrogens are going to be found in a ring structure. So, as you see here in morphine, the solid black line that kind of goes up here and across, these are actual bonds from carbons to nitrogens along that black line. Same thing, over here in atropine, right? You have a nitrogen that's just outside of this ring bonded to carbon down there, and carbon over there. So you don't have to know these structures or anything like that, but I just wanted to show you that these carbon-nitrogen bonds can be found in some rather unusual structures. And this morphine and atropine are both considered alkaloids, which basically means that they're amines that come from plants. The other thing I'll mention about that word alkaloids here, anytime you see the prefix alka or like alkyl, like alkaline, like alkaline batteries or an alkaline solution, that usually means that it's basic. So basic in terms of pH. And one thing that you can remember from talking about acids and bases, we said that amines are always going to be bases. So whenever we look at reactions with amines that are going to come up later in this chapter, amines are going to behave as bases. Okay, so looking at naming amines, so in the case of naming amines, we're going to name them using a very kind of simplified system here. So these are going to be more like the common names instead of the IUPAC names. And the idea for the amines is you see it's an amine and you're going to use the suffix amine. And then for a primary amine, you're going to just say the name of the substituent. So for instance, down here, it's an amine attached to a methyl group. So you're going to call it methylamine. Now, if you come over to this one, that's a secondary amine, right? So this one's a secondary amine because there are two carbon-nitrogen bonds. And you have an ethyl group over here, and you have a propyl group here. So in this case, we're just going to name the two substituents, ethyl and propyl, and then put amine after it, with the idea being that you're going to alphabetize the names of the different substituents. So it's going to be ethyl, propyl, amine. The one in the middle here is a tertiary amine, right? There's 1, 2, 3 different carbon-nitrogen bonds. In this case, they're all ethyl groups. So this one's going to be triethylamine. So if you were to have 3 different substituents, you would just alphabetize all 3 of them. So same rules in terms of the alphabetical order, in terms of ignoring the prefixes if they show up. So again, most of your naming rules are the same. In this case, we're just going to name the amine as the end, and then we're just going to name it by the substituents attached to it. Okay. The exceptions to that are whenever you have aromatic amines. So in other words, you have an N attached directly to a benzene ring. And we talked about this in chapter 11, how we're going to name things as derivatives of aniline. So in other words, this is the structure of aniline, which you should have already remembered from chapter 11. So a benzene ring, this aromatic ring that's here, attached to an H2, is going to be aniline. So now, what if you have that exact same ring, and I'm going to draw it out just as I talk here. If you have that exact same ring, and instead of having an NH2, now I'm going to draw NH, and attached to this other spot, I'm going to write CH2, CH3. So these two structures are identical here. And the idea here on the one that I drew out at the bottom, instead of just saying NH, CH2, CH3, I'm drawing so you can see the 3 specific bonds to the nitrogens. Remember, nitrogens are always going to have 3 bonds in a lone pair. We don't show the lone pair in these structures. So in this case, instead of it just being aniline, we actually have this other group attached to it. The other group here being an ethyl group. So this ethyl group right there, we have to name as a substituent. So basically what we're going to do is we're going to, just like we would with any other organic molecules to this point, we always say you would name and number the substituents. Well, in this case, you can't really number it because it's not attached to a carbon that we're numbering. So instead, we use this N-ethyl aniline to say that it's an aniline that has an ethyl group attached to a nitrogen. So instead of naming and numbering, we're naming it with ethyl, but then we're numbering it. Instead of a number, we're giving the prefix N, and that's the same thing that is shown kind of here, right? So this prefix N basically tells you that's the position where that nitrogen is. So N-ethyl aniline basically means you have an aniline just like this first molecule, but then attached to that nitrogen, you're going to have an ethyl group. And for every substituent you have to take away one of the H's so that you can maintain this idea down here where you always have your nitrogen attached to 3 different things. In this case, the benzene ring, the hydrogen, and the ethyl group. This one over here where it says O-bromoaniline, let's not worry about that O prefix because that's something that we skipped this semester in terms of naming it. But it would actually, another way to say this would be, in terms of your distinction, would be 2-bromoaniline. Because again, whenever you have aniline as your parent chain, let's circle the parent chain here. That's going to be aniline. We're going to number the ring. So 1 to give the next substituent a lower number. So that would be 2-bromoaniline. Right, and that one is an N-bromoaniline because the bromine is not attached to the nitrogen. So again, this structure you should have been able to name before this particular video. This is something that you should have been able to name based on chapter 11 material. And I'm just trying to point out the difference between using the N as a prefix like you see here versus in this case having the 2 as a prefix. Right, 2-bromo, naming and then naming the substituent with bromo and then numbering it with a 2 versus over here we name the substituent with an ethyl, but we're going to number it quote unquote with an N because it's attached directly to the nitrogen. All right, so let's do a couple problems here. Right, how would we name these? Well, this first one here, it's a primary amine. Right, it's a primary amine in that we have only one carbon group attached to the nitrogen, and it's going to be 1, 2, 3, 4, 5 carbons long. So it's going to be an amine. And it's going to be the name for a 5-carbon substituent would be pentyl. So that's just going to be pentylamine. All right, so part B here, we actually have 2 substituents. We have a methyl group here. We have an ethyl group over here. Right, so whenever we have 2 substituents, we're going to alphabetize them. So this one would be ethyl, methyl, amine. So ethyl methylamine would be the second one. All right, and then finally for amines on this one, N,N-diethylaniline. So again, aniline you have to recognize as that structure that has a benzene ring. All right, so this one we're going to draw out. That's going to be our benzene ring with the 3 alternating double bonds. And then aniline itself would be NH2. Right, so that would just be aniline. However, we don't just have aniline here, right? We actually have N,N-diethylaniline. So that means in place of these H's, we have to get rid of the H's. And in place of them, we have to put ethyl groups. So we're going to have to go to, this one is going to be a CH2, CH3 for an ethyl group, and here we're going to have CH2, CH3 with an ethyl group. So this one here would be N,N-diethylaniline.